For problem 6.56, we just know that the voltage at the emitter is 1 volt and that the magnitude, so the magnitude of VBE, the base emitter voltage, is 0.7 volts. And we need to determine the base voltage and current, the collector current and voltage, the emitter current, alpha and beta. So one interesting thing about this problem is that only with those two known parameters here, we can define everything else in the circuit for this particular circuit here. Okay, if we know VE and VBE and the magnitude of VBE, we can determine all those other parameters for this circuit. Okay, one thing that we must be aware is that this circuit, it has a PNP transistor. Okay, so that's why we have magnitude of VBE equals to 0.7, because the potential difference between emitter and base is 0.7 volts. Okay, and we also know that VE here is equals to 1 volt. Okay, now if we look at the circuit and especially to the emitter branch, we know the voltage up here, we know the voltage down here. So if we know the potential difference across a resistor, we can calculate the current flowing through that resistor, right? And in our case, this is actually the emitter current. So the emitter current here in this problem is equals to those 3 volts minus VE, which is 1 volt, divided by those 5k ohms, and that's the emitter current. So if we take 2 divided by 5k, this gives us 0.4 milliamps, and that's the emitter current, i.e. equals to 0.4 milliamps. So we got our first unknown here. Okay, now because we know that VBE is equals to minus 0.7 volts, so VBE, VB here minus VE there, it's minus 0.7, right? VEB is 0.7, but VBE is minus 0.7 volts. It's different for an NPN transistor. For an NPN transistor, if we assume active mode operation, then VBE is actually 0.7, right? So this is just the opposite, which is the same as VB minus VE equals to minus 0.7. We know this voltage, we can calculate the base voltage. So the base voltage, how we use a different color here, VB, is equals to VE, right? If it goes right here, so it's VE, which in our case is 1 volt, minus, that's 0.7 volts, and that's 0.3 volts. So now we define the base voltage here. Now again, if we look at the circuit, we know this potential here, right? And we know this one here, which is 0. So we can calculate this current here, which is the base current. So the base current is equals to that VB minus 0 divided by 50k ohm. And this gives us a base current that's equals to VB 0.3 divided by 50k, and that's equals to 6 microamperes. So up here, the base current is okay. Now, because we know the base current and we know the emitter current, and we are assuming active mode operation, we have another equation that basically gives us beta, right? Because IB is equals to the emitter current divided by beta plus 1. Okay? In this equation here, it comes from the condition that IC is actually beta times IB, and IE is the sum of IB plus IC. So it's IB plus IB times beta. Okay, so IE is equals to IB times beta. This is IC plus IB. Okay, so if we rearrange this equation here, we get this one here. Now we know IE and we know IB, so if we isolate beta plus 1, we get IE divided by IB, which implies that beta is equals to IE over IB minus 1. And we know that IE is 0.4 milliamps, IB is 6 microamps minus 1. This gives us a beta of 66.67. With this beta, so we got beta. With beta, beta here. But with beta, we can calculate alpha. So remember that alpha is equals to beta. It's a value that's always less than 1. So beta divided by beta plus 1. And that's 66.67 divided by 67.67. And this gives us 0.9852. So we got alpha. And one thing is that we also know that IC is equals to alpha times IE. So we can calculate IC here. IC is 0.9852 times those 0.4 milliamps. And that's something around 0.3941 milliamps. So we got IC. And if we look at the circuit here, right, if we know the voltage here, the current here, IC, we can calculate VC, right? Because we know the voltage across that 5K, so it's equals to IC times 5K, and that's equals to VC minus those minus 3 volts. So VC is equals to IC 5K, so IC 5K minus 3 volts, because this one here becomes positive, goes to this side here minus. So VC is equals to IC, those 0.3941 milliamps times those 5K ohms minus 3 volts. And in this case, VC is equals to minus 1.0296 volts. So with IC and VC, let's go up there. We got all the unknowns of the circuit. Okay, so it's very interesting that by only knowing the emitter voltage and VBE, the magnitude of VBE or VEB in our case, we can actually determine all those other voltages and currents and the parameters alpha and beta for that specific transistor. Okay, so one thing is that if we change the transistor here, probably we would get a different with a different beta, we would get a different VE here, and then things would change. But that's a very nice circuit that by only measuring VE and knowing that between emitter and base we have some voltage, in our case 0.7 volts, we can define all the other parameters.